This single replacement reaction is really just a matter of figuring out which metal is going to be most reactive, lithium or calcium in this case. So in order to determine that, we can just look at our reference sheet. This is your reference sheet. Lithium is simply going to take calcium's place. So what you end up with as a result is lithium oxide. And the calcium is going to go free. It's going to go home free. But it's a metal, so it's going to be a solid. And lithium oxide, again, this is going to be a compound, but we have to write a new formula. We can't simply write LiO. Instead, we're going to look at the periodic table and make note of the fact that actually lithium has a +1 charge on it. And lithium being +1 means that it will tend to make one bond. And oxygen is 2-, it tends to make 2 bonds. It tends to gain 2 electrons when it bonds. We crisscross these numbers to write a new formula. So we'll get Li2 and O, okay? I'm only writing that dot above the I as a matter of habit. In chemistry for lithium, it's usually pretty helpful not to write the dot over the I. But again, Li2O1 is your formula, but we tend not to write the 1, so it's lithium oxide like that, plus calcium, and that's a solid. All right, let's do another one. So potassium. Is potassium more reactive than zinc? In order to determine that, what we need to do is just look at our reference. We're looking for example, potassium will replace zinc, and the new formula that you get is potassium bonded to chlorine. Since potassium has a +1 charge and chlorine has a 1- charge, the formula you get is simply KCl. That's fine. And then we get that zinc gets bumped off, and it goes back to being a simple neutral metal, zinc solid. Okay, so KCl and zinc solid is your answer there. Aluminum and copper. Will aluminum replace copper? Let's see. We go back to our list. Aluminum is actually fairly reactive, but what about copper? What is the copper? So aluminum is going to take the copper's spot. It's just going to replace it. So we get aluminum bonded to sulfate. See, this is the sulfate. That's a polyatomic ion. It's an ion that has multiple atoms in it, SO4. It moves as a unit, so we're going to have AlSO4. Well, on your polyatomic ion sheet, you're going to find that sulfate has a charge on it, and that charge is 2-. And aluminum usually is 3+. So what we're going to do is crisscross those numbers just like normal. And what you get is Al2SO4, and we'll need 3 of those. All right? And the result is actually that copper gets bumped off completely, and it goes back to being just a metal. It's shiny, it conducts electricity, it's hard, and that's the result of that reaction. Okay? Let's look at our one more example, magnesium and water. Will magnesium replace the hydrogen here? Well, that's a good question. Look at you replace the hydrogen in water. So you get magnesium bonded to oxygen. This is a 2+ and this is a 2-. So when you crisscross them, you get MgO. You get Mg2O2, but we reduce that to Mg1O1, and we don't write the 1s. So you get MgO plus what was bumped out was actually hydrogen, right? So we get hydrogen gas as a product. That's a gas, and it's an explosive one. You will see bubbles coming out, and those bubbles in this reaction are actually explosive gases. So you want to be careful with this one. We're going to do it in class, but we'll do it very carefully. Okay, that's it for this video. This is, again, single replacement reactions, and we'll talk more about that in class. The activity series. On the top of the activity series is the most reactive chemicals right here. Lithium is extremely reactive as a metal. It tends to replace other metals no matter what they are. On the other hand, gold is the least reactive metal on this list, That means that any other metal will be able to replace it easily, but it will not replace any other metals. And so if we look back at our example, potassium and zinc. Potassium's here, it's way at the top of the list, and zinc is actually way down here. It's right there. Okay, so potassium is more reactive than zinc. It will take its place. And so if we go back to the reactivity series here, there's aluminum right here. Okay, copper come in play while it's way down here. So that means that aluminum will, in fact, replace copper. It is more reactive, and it will treat the reactivity series. The magnesium metal is way up here at the top, very reactive, whereas hydrogen is down here. So magnesium will